Good afternoon, everyone. My name is Srikanth Venkat. I'm a part of the product management team here at Hortonworks, and I'm responsible for the security and governance portfolio. And with me is our co-presenter, Hemant Yamijala, who's part of our engineering organization. And today's topic is we want to cover our new product that we announced, which is actually a service on top of the data plane service platform back in May. We're going to talk about what are the capabilities within the Data Steward Studio, what problems it tries to address, what are the capabilities, maybe show you a demo, and also run through a quick technical overview and maybe a little bit of a deep dive on the site. So we'll start with, very briefly here, and this flashes. It's going, it's not moving. There we go, we'll just use this one, okay. Right, so that's me and Hemant, so we'll just move on to the next one. So Data Steward Studio is part of our data plane service that was announced back in November of last year. And data plane service aims to address this problem, what we're calling our next generation data problems. So we have data sources that both your traditional as well as your data lake and newer stores. We have data in motion, data at rest, and you have some of your data on-prem, some of it in the cloud, and some of it everywhere in both places. And it's going all the way from the edge into the data center, into cloud, and into multi-cloud. So how do you make sense of all of this? Your data is now sprawled all over this landscape. It's in various forms. It's at rest. It's coming to rest. It's in motion. It is structured, unstructured, different combinations. How do you make sense of all of this? How do you get an idea as to how to look at this comprehensively from a single pane of glass? So that is what the Data Steward Studio aims to provide. Let's go to the next slide. So Data Steward Studio and the data plane service as a whole aims to solve this problem of how do we build a data fabric. This is actually Forrester's definition. So what Forrester is looking at is how do you bring these different sources, which may be disparate, building upon the big data technologies like Hadoop and Spark, et cetera, and be able to give this unified, trusted view of all of this data across your entire data landscape. So that is what a data fabric is. And we believe that the data plane service as a whole, along with the Data Steward Studio in particular, is a realization of this concept of a data fabric, a big data fabric in particular. Okay, so here's the kind of a picture. So we have, let's say, a financial services entity. They have data lakes in all of these areas strewn throughout the world. You might have seen a version of this graphic this morning in Arun's keynote presentation, and the definition of some of that fabric stuff that was covered by Forrester also in the keynote presentation. So this is actually the realization of that in the technology stack. So Data Steward Studio aims to provide this view into all of this infrastructure. So you have 3 on-prem clusters in this case. You have 2 in multiple availability zones. And each of these clusters have, for example, Apache Ranger, Apache Atlas, Ranger for authorization and security policies, and Atlas for metadata and governance. All of these are stitched together using this fabric in the middle called Data Steward Studio that provides the capabilities around having a global unified intelligent catalog, having a business glossary coupled with that, and then creation and organization of these different assets that could be sitting across this platform or multiple platforms, wherever they may be, and giving you a single view to look at how do you take an individual asset, a piece of data that could be a Hive table or it could be a file. How do you get a 360 view of all that's important about that file? How do you understand the data? And then also keeping in mind that you want to have the rational security and controls around this, both from a data perspective and also from a metadata perspective. So that's what Data Steward Studio represents. So take a little bit of a step back. So you saw this morning also in part of Rob's presentation, so Rob Bearden's presentation. So you see that the data plane service is intending to solve this problem by unifying all of the data, whether it's in data in motion and data at rest, in HTTP or HDF, and across all of these environments, whether it's hybrid, multi-cloud, IoT, et cetera, and also across multiple cloud providers in this case, to be able to give you that single view of all of this infrastructure and giving you all of this data supply chain across your entire landscape that might exist in your companies. So What is the focus of Data Steward Studio is to help you with the data governance tasks, which have become very critical with all these new regulatory and compliance mandates that are being thrown at us, GDPR and others in particular. So, and who is it targeted at? It's targeted at these two personas. The business side of the persona, which is the data steward, they're responsible for the business definitions, the classifications. How do you set up the right policies to satisfy any compliance requirements, regulatory requirements, and responsible use of that data across your enterprise. And then the data curator, you can think of them as the IT implementation of what the business data stewards define. And they are the people who are actually implementing those policies, making sure that that is realized in the software and infrastructure that exists within this environment. So Data Steward Studio is kind of targeting these two sets of personas and this audience in terms of the feature set. Okay, let's go to the next slide. So this is a one-slide summary of all of the features that exist today and the purpose for each of the existence of Data Steward Studio. So essentially, Data Steward Studio, the way to describe it is using the word discover, where each of these letters stand for a particular function involved with the organization, governance, and getting that fabric view holistically across your entire data landscape. So starting from the top in the middle, so Data Steward Studio has profilers that will let you go look at content, scan the content, and figure out where sensitive data lies and annotate that using the metadata systems that exist. In particular, annotations get pushed back into Atlas, so you get visibility into the same information from one pane of glass based on that content. The next idea here is inventory. So you need to be able to look at this holistically across your entire data landscape and have an inventory of all of the sensitive assets and other assets, so you can make the appropriate business decisions around who needs to see this data, how does it impact their workflows, and how they can be realized in practice. Security is pretty critical given all of the other mandates for compliance, regulatory, whatever else is coming up, as well as your responsible use of your data, not to violate any of these policies, and to make sure that you have the right protection in place especially for your customers' data. So security, both from a data perspective and also from a metadata perspective. One of the key things that we bring to the table, and then you will see more of this as you work through the conference, in particular in Atlas and Ranger combination, we are now introducing the concept of metadata security. So you will now be able to determine who gets to apply a particular classification to a particular type of object or entity that exists in the ecosystem. It's very powerful and unique. I don't believe there's anything in the big data space that addresses this capability. Another manifestation of this metadata security could be, for example, you have a data profiler that runs, and then that creates annotations for max and min, et cetera. You've actually locked down the real data using, let's say, a Ranger security policy. That person has no business to actually see the metadata, which is leaking this information. So the max and mins actually represent values in the column, so those should not be visible to the customer. Thanks. So that's the security portion. Data Steward Studio also has collaboration features. So as we mentioned before, the data governance activities are a team sport, requires collaboration across many different types of actors in the enterprise. So we have some crowdsourcing, rating, threaded discussions, those kind of features built in. So you can now share your knowledge about these data assets, how they're being used in your enterprise, and share other information, interesting information about shape, other characteristics of this with others, and have a collaboration venue for that within the tool. Organization. So Data Steward Studio provides a very foundational organizational construct called an asset collection. Think of this as being able to very flexibly search and define criteria, business criteria by which you want to group certain assets. So one example could be, let's say you're a healthcare provider and you want to create an asset collection that represents your patient data. So the patient data could be living as, let's say, for example, in HDFS, you could have files that have the X-rays and other image data, unstructured sources, and you could also have other transactional data that are coming from a provider's office that is now mastered in Hive, in a Hive table. So you could take a combination of structured and unstructured sources that pass this filter to say, do they contain any kind of customer identifiers, et cetera, group them together and create an asset collection. And the benefit of that is now you can use that as a common currency for collaboration across your enterprise. You can share those asset collections. You can put the right permissions around those. You can tag those, and you can get more information about the assets within those in a unified fashion. So this notion of organizing the assets and curating the assets is a very foundational concept. You will see this being expanded as we have more and more services into the data plane fabric. You will have the notion of asset collection pervade across other services. For example, in our data lifecycle manager service, we're not able to do that today, but in the future, you'll be able to define an asset collection in Datastore Studio and be able to say, now replicate this out into the cloud because this is the data set that my data scientists want to run their models on. So we will be able to now use that as a common currency for how this information gets shared across the enterprise. I think there's a timer on this. It keeps coming back. All right. The other three key areas that Datastore Studio addresses is the verified bucket here. This is where you need to understand your chain of custody. So where did this data come from? Is it reliable? Is it a trusted source? So you will be able to determine what the source is, how it evolved and landed in this current form in the data lakes. Enrich, this is your putting your business classifications and other types of tagging and business glossary terms, associations, etc., to add and enrich that experience that you have with that asset. And adding more business context to it so it becomes more usable and more shareable and valuable across the enterprise. The last piece here is reporting. We have a lot of dashboards and different types of information being surfaced about both at the asset level, at an asset collection level, and also at a data lake level. And you will see some of this as we run through the demos. Okay, cool. So I want to exit out of here. So let's show. Yep. All right. So what you're seeing here, I can get to this. This is the data plane admin console. So I'm going to actually log back in just to show you what there's a critical piece here. So the way Data Steward Studio is constructed is it's an app sitting within the data plane infrastructure that can be deployed anywhere. You don't have to deploy this off cluster. You can choose to say, for example, you have a hybrid environment, both cloud and on-prem. You can choose to deploy data plane within your infrastructure locally in your data centers, and then that will still have visibility into other clusters that may be either on-prem or in the cloud or in multi-cloud environments. So the notion of data plane is that providing you that central ability to register different types of data sources. We are starting with the data lakes, in particular HDP, clusters that may be across the world, in different cloud providers or within your data center infrastructure. The first notion is the concept of being able to register these different data lakes that exist into this platform. So what that lets you do is gets you a unified access into all of that data and helps you manage security and governance across that holistically and uniformly and comprehensively. So we'll see here. So first, let's log in. So the persona we are dealing with is a data steward who works in the data protection officer organization, which is mandated by GDPR, that anybody who's handling personal data of European subjects needs to have the data protection office set up. Get out of here. So in this case, what you're saying is this is if you've heard a bunch of our demos on security and governance, this is our favorite Hortonworks bank. It is a mythical multinational bank who has operations in US and EU. In this case, we're showing the EU footprint. There are 3 data lakes that are registered. There's Prague, Frankfurt, and Dublin. They all have different types of data. You can see that one of those is actually down and it's not healthy. The other 2 are in okay shape. So you can zoom in and look at this information. You can also look at, go directly to the Mbari if it's active, and you can register other data platforms. The registration from the other platforms is very straightforward. You give it an Mbari URL. There are agents that you drop on the clusters themselves. So, for example, the Data Steward Studio has 2 pieces. There's the data plane application, which is this UI that you see here, that is going to live off cluster. And there is an agent that you can drop on each of the individual clusters for local performance and optimization. So all the work and heavy lifting is done locally in that cluster, and the results and annotations are persisted back into the cluster. They are just surfaced up nicely in this UI that you would see. So registration implies that all you're doing is you're connecting to that and making that data available from this central fabric or central pane of glass. Go back here. So we looked at all the clusters that are registered. You can set up different roles and different users. All of this is wired into a single AD or other LDAP type of sources. What you saw on the login page is actually single sign-on via Apache Knox. So as long as you've got Knox enabled on your clusters, Data Plane Service also has, the DPS platform also has a Knox instance, and that can be wired up to go to any one of your SAML or OAuth type of sources, consume those tokens, and pass that identity into the cluster. So if you log in this case, we logged in as Michelle, who's part of the DPO organization. Her identity is now passed to every cluster that's registered to Data Plane. So you will only be able to do whatever authorized operations Michelle is authorized to do on those individual clusters. So that way we can maintain a clean security boundary around it and make sure that only the people with the right privileges are able to do the right actions in the individual clusters. Now this is on top of that, within the Data Plane application, Data Plane suite of applications themselves, there's a Data Steward Studio, there's a Data Lifecycle Manager, and soon we'll have CloudBreak and the Kafka Streams Messaging Manager that we'll talk about in the Demopalooza later today. All of those can now be authorized using the single interface. So this gives you the ability to map different individuals to different roles. All of these are sourced in the AD, so you can go look at this. This is wired up to an AD. You add a user, you will see all that information here. Okay. You can also choose which services are run on which cluster. So in this case, the Data Steward Studio is running on those clusters. You can go look at that, so it'll automatically pop up with where it's been enabled. You can also do certain things for certificate management, especially for SSL, between the Knox that's sitting in the cluster and the Knox that's sitting in DPS. Okay. All right, so this is all about, so far we have not looked at Data Steward Studio at all. This is all of the Data Plane infrastructure that supports Data Steward Studio. Let's go look at the Data Steward Studio application itself. So Michelle is now logged into this, and then the first view that she sees is like a big picture of all of the asset collections that she has access to. So let's say she wants to first understand what's in one of my data lakes. So you can go click on this. You'll see this is running probably over VPN. Okay, there we go. So we surface these dashboards that have some very interesting summarizations about all of the data that's sitting within that cluster. So in this case, we have 38 assets, 38 Hive assets in this case, Hive tables. All of them have been profiled, and there are a variety of profilers that come with the Data Steward Studio. We have a flexible profiler framework, which is highly available, scalable, uses Spark as the underlying machinery, and you can now extend that to also include your own types of profilers. Out of the box, we have 4 profilers. We have one for sensitive data detection, so this can go scan all your Hive columns across multiple data lakes and surface where you have, like, for example, credit card numbers or passport numbers, other types of sensitive information that are important. The initial set that we have profilers for covers a subset of the GDPR requirements. So all of your national IDs for the 28 member states in EU, and passport numbers, telephone numbers for those areas, national IDs for those areas, as well as your US-based social security numbers, credit card numbers, PCI, PII, and personal data. So we've got an initial cut of this, about 70 plus elements that we can already detect. So that is what is shown here, is to say now out of the 38 Hive tables that we have in this cluster, we've got 12 that are sensitive and 26 that are not sensitive. So at a table level, you get a very high-level picture to say how many of your tables that have at least one piece of sensitive data in their columns. Then this is the next widget here shows you the rate of addition of this, so you can see how you're adding or removing assets in this particular environment. You can see how the profilers are running. And then this is other interesting and useful information. This is showing you what are the top assets that are being accessed in this. So this is showing you, for example, this worldwide customers table, which is part of this asset collection, is the most used asset in this case, in this data lake. And then you also have this data asset collection. So that is there's only one that is being used here that is very heavily used in this case. Okay, so that's the data lake view. We also have this notion of all of these different data asset collections. Let's look at the one for which we saw those summaries. So this is a customer data asset collection that is coming from potentially a CRM system. And you can see that it has two tables, and the two tables are a worldwide customers table and a US customers table. And both of them have been profiled with the sensitive data profilers, and those summaries have been provided here. So you can see that there are two columns within these two tables that have telephone numbers, one that has social security number, one has two emails, etc. And then all of these profiler runs have been successful, and they've found two sensitive columns in here. This is a user-centric view of the access. So you can see that amongst all of the assets within this particular asset collection, the Sasha, who works for the HR department of this bank, is a top user. So that person's tried to access this 200 plus times over the last month. So you can filter this down to a week or to a day, etc. Okay? And then you can also see other patterns here around sensitive data access. Let's go back and look at. So once you build this asset collections, what can you do? So you've seen that you get a high-level summary of the usage patterns. You get a summary of the sensitivity nature of the assets within that collection. And you also have what we are calling an asset 360 page. So what this gives you is a view into all of the interesting information about an individual asset. This could be a Hive table, in this case, as we're showing. So you can see that this has 50,000 rows, 40 columns. The sensitive data profiler has run automatically, and then this surface three sensitive columns. You see the Atlas lineage graph here. You see a bunch of metadata properties coming from Atlas. And you see from the aggregation and summarization of the Ranger audits, we are now able to determine who are the top users who touch these assets. You can see how many of the access requests came in over a period of time, how many of them were actually allowed, and how many were blocked by maybe Ranger security policies that you had on those assets, and then what types of operations were attempted on that particular asset. So this gives you kind of like a usage picture, a high-level metadata picture, and you also see here the status of all of these profilers that have been run. So there is a Hive Metastore profiler that is used to create one of the widgets that we saw on the data lake dashboard that shows how the rate of addition or deletion of assets happened over time. There is the audit profiler that is used to summarize and show you this access information. There's the sensitive data profiler that is going to go look at the columns and classify them as having sensitive data of certain types that the profiler detects. And the last one is a Hive column statistical profiler that we'll look at when we look at another detail page here. So you'll notice that there's also these auto-suggested tags. These are system tags that the profilers have automatically gone and determined as appropriate for this particular asset. In this case, there are three columns that we looked at. So there's probably potentially one or more columns with a credit card, one or more columns with email, and one or more columns with a telephone number in them. And we can see which one those are in a different view, which is the schema view. So once you go into this view, you can see, you can get an understanding of the shape of the data, and you can also get some information about the auto-classified sensitivity picture of this particular table. So in this case, you see that we're running a profiler that goes and summarizes all of the data. It does a deep inspection of the content, and then looking at the set of sensitive data patterns that we recognize out of the box, and using a combination of NLP on the column headers, etc., it builds up a confidence number to say, I think this particular MRN, whatever that name is, the column has content that looks like a telephone number. So it is suggesting automatically that there is some sensitive content within those columns, and you can schedule these profilers to run, according to your whatever your ingest frequencies are and how much of these assets that you have within your environment. So let's look at what else is shown here is the Hive column univariate statistical profiler that goes and looks at this content, gets other statistical information such as max, mins, and then the types, cardinality, missing values, and null values, and also shows you a distribution of values. In this case, this is numeric data, so you see a histogram and a box plot with the fine number summary on the right there. If you have other categorical information like credit card numbers, you will see other charts such as pie charts here. Okay. There is also a bit of workflow built in. So we said that the Data Steward Studio's sensitive data profilers can be scheduled to run on demand, and you can see on demand or on schedule. So in this case, this data was profiled about 3 hours ago, and this was a full profile, which means we exhaustively looked at every single row within that particular column before we created these summaries. And you can do a sampled, or you can do a full, anything in between. So you also see here that when I do an edit, that some of these, there's this dialog that opened up, and you can go look at the tags that have been suggested by the system, and you can either say, I don't think this is right, this is actually a medical record number, so this should not be telephone. So you can delete those and save those, in which case that tag or association with that column will be removed. In case you approve it, you could just say save, and then those will turn blue. So I'm not going to do that. I'll just do this deletion and then save it. So once that gets saved, you will see that this will turn blue. I don't know what's going on here. It's probably VPN or. All right. So you have to come back and look at it here. Scheme again. There we go. Okay. So those were saved, and then you have a workflow that can be built in. So what will happen in this case is when the tag gets saved, the association of the column to that sensitivity gets persisted back in Atlas locally. And if you have any range or security policies that say when anything that's tagged as email, I want to have this type of access for my users, or maybe I want to mask it in a certain way, all of those security policies will kick in and will be enforced based on the auto classification and the curation that's being done by the data stewards here. You also see on a particular asset all of the security policies, the range of policies that are set up on that. You can also see all of the audit events and then explore them in more detail. We also have a profiler here. Profiler settings UI here, you can go look at all of the profilers, what profilers have been run, where, and what was the status of those, and you can also make some changes to some of the minor configuration details here around whether you want, like, which queue do you want to run it in, and whether you want like a full sample or you want to do a partial sample. So you can set properties and modify them. In the future, we'll be able to define your own profilers with different types of content scanning, different types of summarizations, and also be able to use things like, you have your own algorithmic checks, or maybe you provide an inclusion and exclusion list, or maybe you provide your own regex or other patterns that you can look at. So we plan to make this an extensible framework where you can write your own custom profilers to do any kind of annotations and summarizations and use them in further, in any further processing that you do based on this data. So we saw in brief, switch over here to PowerPoint. There we go. So go back here. So we saw all of those. So we were able to detect the sensitive data. We saw a catalog. You could go search on this and build asset collections. We saw all of the security policies in place. We saw how, actually, we didn't show you the collaboration. Maybe we should do that. It's collaboration feature. Yep. There. Cool. So if you look at this, asset collections. In an asset collection, you can also do favoriting and ratings of these. So you can rate these asset collections and collaborate with others on it. Then you can also add comments in here. So for example, you want to indicate that maybe this data set is suspect and don't use it for building your machine learning model. So you can provide those types of annotations here and share those across different users. There's also capability to build new asset collections, and those can be done very simply. You go do a search and you find data. So in this case, you can pick which data lake you want to search on. And let me just put in some test parameters here. Yeah, that's fine. Yeah. Oops. There we go. And then you can find assets very simply. This is very similar to an asset search that you would see in Atlas because it's under the covers using the Atlas search on those clusters. You can go in here and say, show me all the assets that have, let's say, US. So all of those that have the US in there. You can also do a faceted search. You can go show me all the assets that are owned by this user called Hive, etc. So once you've built this, you can continue this operation to search, to find those assets, stuff them into a collection, and then you'll get all of those nice dashboards and the ability to explore the Asset 360 pages on each of these assets. This page that we looked at for a particular asset, we're calling that the Asset 360 page because it gives you a complete picture of all of the different characteristics, like the shape, the sensitivity, other metadata. And then you'll notice all the auto-suggested classifications, usage patterns, all of these in one place. So we're calling that the Asset 360 page, kind of like the Facebook page for your data, for that piece of data. Then you can add additional annotations and comments and collaborate further with others in your enterprise on this. Okay, so I'm going to shift back here to the point. Take over. No, still back there, I think. There's a toggle. Cool. All right, so we looked at the demo. I'm going to skip through, and we have about 7-8 minutes to cover. So I'll hand it off to Hemant. So he's going to cover a little bit of a technical overview of all of this infrastructure, how it works.
Cool. Okay. Thanks, Srikanth. So that was a fairly detailed view into what the functionality and the capabilities of this product are. So time to switch gears a little bit now and focus a little bit on the technical side of things so that you have a full picture of how things work behind the scenes. So I'll keep it to the crux of what matters, and if you have more detailed questions, we can catch up offline as well, because I think we are running out of time. Just a quick picture. Right now, I'm sure that all of you understand that Data Steward Studio is a part of the data plane services. One thing that is important to cover is it is one of the several services that snaps into data plane. And there is something called the DPS platform, which is like a core set of capabilities that are provided for all of the services that snap into it, right? And the DPS platform takes care of things like authentication, role-based access, and so on. So many of the things that Srikanth showed in the demo about single sign-on capabilities, how do you register a new cluster, and all of that. So those are functions that are satisfied by the DPS platform, and the data that is managed by it is exposed to other services through APIs, and they can use it for whatever they need, right? And the other point to call out is typically you have two parts to a data plane component as such. So you have something that snaps into the data plane side, and then you have some component that goes onto the HTTP or HDF cluster typically. Srikanth touched upon this briefly. So for example, in the case of the Data Steward Studio, we have the profiler service, which is an Ambari managed service that is installed on HTTP nodes. And it is a profiler service that does a lot of the heavy lifting for most of what you saw in the demo, right? All of the classifications, all of the summarization of data, the data shape detection, and so on and so forth. All of that is the job of the components that come with the profiler service. So it's using the native HTTP capabilities of Yarn and Spark and other things. And the front end, the application, the Data Steward Studio itself is just the view that kind of gives you that summary of what is happening. Okay? And this is the general pattern for most of the things that you see in DPS today, right? So DLM has a similar architecture where you have the DLM app on the data plane side and the DLM engine, which actually does the replication, right? So that's the architecture that you will likely see. I'm going to skip this a little bit. Let me sort of talk about the architecture of DSS. So on the data plane side of things, the Data Steward Studio is just a web application. We've used it, we've built it based on Play Framework in Scala. And the UI is powered by Angular, right? So Scala is picking up in terms of the Hortonworks suite of technologies also, right? The data that you saw about asset collections and things like that, those are all stored in a Postgres database right now, which is shared with the rest of the data plane services. On the cluster side, we use pretty much most of the components that come as part of the HTTP security and governance stack, Atlas, Ranger, and so on, right? Shrikant mentioned that we do a single sign-on between data plane and the services on the HTTP cluster. This is very critical, right? So for example, the user who's logged into DSS, his identity is transferred via Knox single sign-on into the HTTP services. Therefore, anything that is restricted on the HTTP services in terms of what the user can or can't do is automatically applied. And this applies for every cluster that is managed in data plane, right? So it gives a very consistent and easy to understand method of what the user can or can't do, even though we are centralizing all of this into one place, right? So the model is very clear. So that is why you see that most of the communication that goes to from data plane is all channeled through Knox, right? So we use Atlas and Ranger for all of the metadata and the security related information that you saw, like the policies and the audit trails and so on. The heart of the system, of course, is the profiler service, right? Before we get there, let's switch a little bit and look at the profilers, which are essentially Spark jobs. And Shrikant mentioned and showed there are 4 of these, like the Ranger audit profiler, Hive column profiler, and so on. So these are just Spark applications that utilize the capacity on the Yarn cluster. And by virtue of that, they are scalable, right? So we've used technologies that allow you to work with a big data framework in general, right? So what these profilers do is they looked at Hive and HDFS data. They run, they process the data according to what information they want to get out of it. Like, for example, sensitive data profiler would look at a sample of a Hive table, match it against different regular expression patterns and things like that, and say, all right, it looks like these columns in these tables seem to have sensitive information, right? So that's the kind of data augmentation that these profilers do. And once we get that information, we either persist them as summary files on HDFS. These are standard serialized files like Parquet or ORC and so on. Or we would write some of the classification type information into Atlas, right? So those are the 2 sources from where Data Steward Studio picks up the information, right? The dashboards that you saw are interesting. The profiler service actually uses the summary files on HDFS and uses Livy as an interactive session handler for just reading these files and serving them out interactively, to the front end, right? So you have the profilers, you have this Livy interactive session and all that. So the management of this whole framework of jobs, that is actually done by the profiler service, right? So it is like the controller. It's like the guy who's coordinating everything, okay? He's the guy who's keeping track of what assets need to be profiled, how frequently do we need to run the profilers, right? And are the profilers run properly or not, and so on, right? So the analogy we try to provide is, think of this as like a crawl index framework, like your web search, right? So your assets are your Hive tables. Your profiler service is like your crawler, right? That's the guy who's kind of detecting what needs to be profiled. And then your profilers are different indexers, right? Each profiler is an indexer that adds a different type of an index, a sensitivity index, a column summarization index, whatnot, right? And all of that information is, the index is stored either on HDFS or in Atlas. So that's kind of like a mental picture that you can use to provide that. So it's important to note that we are thinking of the profiler framework itself as being extremely extensible. We have 4 profilers that ship out of the box right now, but we do expect that more people, including us, will add more profilers as we go on, right? So the profiler agent exposes APIs through which you can register new profilers. You can say, here are my Spark jars. You can load them here. Give them configuration details, like how frequently do you want to run them, which queue do you want to submit to, what job configuration, and so on, right? And you can also, the profiler agent then launches these jobs, monitors the status, and makes sure that everything is working fine, right? So that's one of the things that it does. So the other part is in addition to the extensibility aspect, the other part that is important is the performance and scalability aspect, right? So we want to make sure that we are running on a big data system. So we need to make sure that we have the controls and knobs there to say Let's make sure that we have back throttle, back pressure applied. If your cluster is getting full with Spark jobs, then we make sure that we hold back and don't submit enough. So all of that intelligence is something that the profiler agent will manage for you, right? So yeah, I'll probably skip this and just give a quick look at the 4 profilers that we have today. There is the sensitivity profiler, which looks at a sample of every Hive table that's there in your system and matches them against different regexes that we have and detects the tags that need to be added onto these columns. And then the tag workflow that we showed kicks in, wherein the user can accept or reject these tags and build policies based on that. So it gives a complete end-to-end picture of new data coming in, getting tagged, the asset being viewed on the DSS, acceptance, policy-based management. Like you see the picture, right? So all the dots are connected from that perspective in terms of how you manage this. The table stats profile is the one that showed all of the shape of data graphs, like the histograms and the pie charts and so on. This is very intensive. It looks at all of your Hive table data in order to come up with these summaries. And therefore, we don't run it on every asset that's there in the system. We allow you to tell us which ones to run on by virtue of creating an asset collection. So basically, you create an asset collection, you add some assets to it. That is what triggers the table stats profiler to say, all right, you're interested in this, I'm going to get you the statistical data of this, right? So that's the way it works. The audit profiler is the one that showed the top users and usage and so on and so forth, right? So, and it's a very, very important profiler from the perspective of what we have in the system. It looks at the Ranger audit files. So in order for this to work, you actually need to make sure that Ranger audit is turned on to persist to HDFS. And the audit profiler then looks at scheduled frequencies in the audit files and extracts all information about who is querying what data, at what frequency, what types, and so on. Summarizes all of them, puts them onto HDFS, and that's where we serve it out of like Levy sessions and stuff like that, right? Makes sense? Okay, and then there's the Hive Metastore profiler, which kind of looks at the metadata itself. I'll kind of end here. The other information is covered through the demo and other things that we showed. So we'll be happy to take some questions, or we can talk offline too.
Is this available for us to download and try?
Yep. This was released as GA.
This is generally available as of
in
mid-May.
May.
The open source repositories are in the process of being created and pushed out, so you
Yep.
will be able to see all of this code for entire data plane, including the DPS, DSS, DLM, and all the profiler agents. Everything is open source. And we just want to kind of end on this to show you what the capabilities are. And if you want to learn more about some of the underlying technology improvements, please do check out these sessions. So we have things on Apache Atlas, all of the new capabilities that we'll be leveraging in the future, and also for Ranger tomorrow. Then we have a GDPR crash course in case that's of interest for you. There's Birds of a Feather, where you can come and bring your questions about DSS, any topics on security and governance. And we also have a partner community showcase where different vendor partners will come and talk. In particular, we have Attunity, Privacera, and IBM talking on Thursday in the session. So welcome all of you to.
Yes, just quickly, what are the next profiles you have on the horizon? Is there a message for HDFS?
Yes.
Yes.
So, yeah. That is going to be a very big key item. So we want to be able to detect different types of content based on metadata and also based on the structures or unstructured data within there. Say, for example, using things like Apache TCAT to detect what type of file it is, and then getting metadata around that and summarizing those, maybe even doing a deeper content inspection, having some machine learning type of approaches to correlate maybe what type of topic or what is the content in there. So surfacing all of those.
And that said, that is one area where feedback from you guys will be very useful about what is it that you would like to see in terms of the filing capabilities.
And this is totally extensible also, so you can write your own profilers based on this framework. Okay. Thanks, everyone.
Thank you
for your time.
Thank you.